June 1944. A Royal Air Force Spitfire spins toward the English Channel, trailing smoke from its shattered engine. The pilot, Flight Lieutenant Owen Baggett, has perhaps 30 seconds before the aircraft becomes uncontrollable. His primary weapons are gone, ammunition exhausted in the engagement that crippled his plane. The cockpit is filling with smoke. He reaches for the standard emergency equipment stowed behind his seat, a flare pistol, 27mm bore, loaded with a single red pyrotechnic cartridge designed for signaling rescue aircraft. Not for combat. Never for combat. A Messerschmitt Bf 109 closes from above, positioning for the killing pass. The German pilot assumes the Spitfire is finished, but protocol demands confirmation. He drops altitude, moving within 50 meters to verify the kill visually. Baggett pushes the canopy open. Wind tears at his face. He extends his arm, holding the flare pistol, and fires directly at the approaching fighter. The flare strikes the Messerschmitt's engine cowling and ignites, burning at approximately 1500 degrees Celsius. Magnesium and strontium compounds pour white-hot flame across the German fighter's nose. The Bf 109 banks violently away, trailing smoke. Baggett never sees what happens next. He is already bailing out. He survives. The Messerschmitt does not return to base. No wreckage is found. The engagement is recorded in RAF intelligence reports as unconfirmed. The flare pistol is never mentioned in official accounts, but word spreads among fighter squadrons that standard emergency equipment used in desperation at close range can damage or destroy an attacking aircraft. This was not doctrine. This was survival. The problem facing combat air crews in World War II was immediate and visceral. When primary weapons failed, when ammunition was exhausted, when hydraulics froze or electrical systems died, pilots had seconds to respond before enemy fighters closed to lethal range. Standard sidearms, typically .38 caliber revolvers or 9mm automatic pistols, were useless against aircraft. The effective range was perhaps 25 meters under ideal conditions. Penetration of aircraft aluminum was possible, but unlikely to cause critical damage. The rate of fire was too slow. Accuracy from a moving, damaged aircraft was essentially zero. What pilots needed was a weapon that could be deployed instantly, that required no sophisticated aiming, that delivered effects substantial enough to deter or damage an attacking aircraft, and that was already present in every cockpit as standard equipment. No such weapon existed officially. The flare pistol existed for signaling. It was designed to project pyrotechnic charges visible at distances exceeding 10 kilometers, allowing rescue aircraft to locate downed crews. Every combat aircraft carried one. Most carried multiple flare cartridges of different colors for various emergency signals. The pistols were simple, single-shot breech-loading designs. Barrels were typically 27mm in diameter, though some variants were as large as 40mm. They fired low-pressure cartridges containing magnesium, strontium, or phosphorus compounds suspended in a matrix that burned intensely for 5 to 15 seconds while drifting on a small parachute. These flares were never intended as weapons. Their ballistic properties were poor. They traveled at low velocity, approximately 50 to 70 meters per second. They had no aerodynamic stability. Accuracy beyond 20 meters was essentially random. They were, however, intensely hot and nearly impossible to extinguish once ignited. The first documented instance of a flare pistol used in aerial combat occurred in 1941 over the Mediterranean. A Bristol Blenheim bomber, damaged and out of ammunition, was attacked by an Italian CR-42 biplane fighter. The Blenheim's rear gutter, having expended all machine gun ammunition, fired a flare pistol at the approaching fighter. The flare struck the CR-42's fabric-covered wing and burned through, causing structural failure. The Italian aircraft crashed. The incident was noted in squadron records but dismissed as exceptional luck. Similar incidents followed. A Soviet Il-2 Sturmovik pilot over Stalingrad in 1942 fired a flare at a pursuing Bf-109, striking the fighter's canopy and forcing the German pilot to break off. A U.S. Navy Wildcat pilot in the Pacific, ammunition exhausted after engaging multiple Japanese aircraft, fired a flare that passed through the propeller arc of a pursuing Zero, causing the fighter to veer away. Whether this represented actual damage or pilot's instinct to avoid the burning projectile was never determined. These incidents shared common characteristics. They occurred at close range, typically under 50 meters. They involved aircraft already damaged or at extreme disadvantage. They were acts of desperation rather than tactical choice. They were not recorded in official after-action reports as weapon engagements because flare pistols were not classified as weapons. Yet they accumulated in the informal knowledge base of combat aircrews as possibilities when all standard options were exhausted. The flare pistol itself was mechanically simple. The standard RAF model, the Webley and Scott Mark III, had a barrel length of approximately 20 centimeters. Total weight unloaded was roughly half a kilogram. The breech opened on a hinge, allowing a single cartridge to be inserted. Closing the breech cocked the hammer automatically. Pulling the trigger released the hammer, which struck a percussion cap, igniting the propellant charge. The flare exited the barrel with enough velocity to reach altitude, but not enough to penetrate metal effectively. The American M8 flare pistol was similar in design, slightly larger at a 28mm bore, with comparable performance characteristics. German pilots carried the Walther Leuchtpistole, a 27mm model that functioned identically. All were single-shot weapons requiring manual reloading between shots. In conventional flare usage, this was acceptable. In combat, it meant one chance only. The flares themselves varied by type and purpose. Red flares signaled distress, green indicated safe return, white was used for illumination. All burned at temperatures sufficient to ignite fabric, wood, and some metals. Magnesium-based flares burned at approximately 1500 degrees Celsius. Phosphorus compounds reached 1800 degrees. When these compounds contacted aircraft surfaces, they adhered and continued burning regardless of airspeed or altitude. Fabric-covered control surfaces could be destroyed completely. Metal surfaces could be warped or punctured. Plexiglass canopies could be melted. Fuel lines, if exposed, could be ignited. These effects were incidental to the flare's design, but became relevant when the flare struck an aircraft rather than empty air. Testing of flare pistols as weapons never occurred officially. Doctrine prohibited their use in combat. Ammunition procurement, aircraft armament specifications, and tactical training all treated flares as signaling devices exclusively. What testing did occur happened in combat, documented only in pilot debriefings and informal accounts. The effective range for flare pistol use against aircraft was established empirically at approximately 15 to 30 meters. Beyond this distance, the flare's trajectory became too unpredictable. Closer than 15 meters risked the flare's exhaust damaging the firing aircraft. The optimal target was an aircraft approaching from directly ahead or slightly above, where relative closure rate was highest and aiming requirements were minimal. Deflection shots, attempts to hit aircraft crossing perpendicular to the firer's path, were uniformly unsuccessful. The flare's low velocity meant lead calculations were impossible under combat conditions. The psychological effect on enemy pilots was substantial but difficult to quantify. A flare igniting nearby represented an obvious threat. Pilots instinctively avoided burning objects, particularly those moving unpredictably. Several documented cases exist of enemy fighters breaking off attacks after flares were fired, even when the flares missed entirely. Whether this represented rational threat assessment or instinctive response cannot be determined from available records. What is certain is that German, Italian, and Japanese pilots learned to recognize flare pistol discharge and modify their tactics accordingly, maintaining greater separation from damaged enemy aircraft and approaching from angles that minimized exposure to flare fire. The tactical limitations were severe and numerous. The single-shot capacity meant no follow-up was possible without reloading, a process requiring 15 to 20 seconds under ideal conditions and essentially impossible in combat maneuvering. The low muzzle velocity meant the flare had significant drop and drift, requiring the target to be very close and the firer to aim high. The burning time of 5 to 15 seconds meant the flare could theoretically be avoided simply by maneuvering away and waiting for burnout. The lack of fragmentation or explosive effect meant damage was entirely thermal, requiring direct contact with vulnerable components. Most critically, using the flare pistol required opening the canopy or side window, exposing the pilot to the slipstream, reducing vision, and often causing additional control difficulties in already damaged aircraft. These limitations meant flare pistol use remained exceptional rather than routine. Pilots who survived long enough to exhaust ammunition and face subsequent attacks without defensive capability were already at extreme disadvantage. Adding the complexities of flare pistol employment offered minimal improvement in survival probability. The weapon's value was primarily psychological, providing pilots with an action to take rather than passive acceptance of destruction. Comparison with other improvised aerial weapons provides context. Soviet pilots occasionally threw empty vodka bottles at pursuing German fighters, hoping to damage propellers or canopies. This was entirely ineffective, but psychologically satisfying. German pilots in the final months of the war reportedly attempted to ram Allied bombers after ammunition exhaustion, a tactic that was occasionally successful but invariably fatal to the ramming pilot. Japanese pilots formalized this approach in the kamikaze doctrine, which eliminated the distinction between weapon and platform. British bomber crews occasionally fired Very pistols, similar to flare pistols but with slightly higher velocity, at night fighters. The success rate was negligible, but the practice continued because alternatives were non-existent. American bomber crews developed the practice of throwing .50 caliber ammunition into slipstreams during fighter attacks, hoping the tumbling rounds would strike pursuing aircraft. This was similarly ineffective. Among all improvised aerial weapons, the flare pistol was unique in having documented successful engagements and, however small, some probability of affecting enemy behavior. The specific case of Flight Lieutenant Owen Baggett requires examination beyond the opening narrative. Records indicate Baggett was actually a U.S. Army Air Force pilot, not RAF, flying in the China-Burma-India theater in March 1943, not June 1944 over the Channel. His aircraft was a B-24 Liberator bomber, not a Spitfire. The sequence of events differs significantly from the condensed account. Baggett's bomber was shot down by Japanese fighters. He bailed out. While descending under parachute, a Japanese fighter approached to strafe him, a war crime but common practice in the Pacific theater. Baggett, still carrying his service pistol, played dead. The Japanese pilot closed in to approximately 10 meters to verify the kill. Baggett drew his .45 caliber pistol and fired multiple shots at the cockpit. The fighter veered away and was later reported crashed. Whether Baggett's shots caused the crash or the pilot simply left after seeing apparent defensive fire remains disputed. Baggett survived and was captured. He spent the remainder of the war in Japanese custody. This account, though historically documented, does not involve a flare pistol. It has been merged in popular accounts with other incidents involving flare pistols to create composite narratives that are more dramatic than individually accurate. This process illustrates how exceptional events become folklore, modified in retelling to emphasize particular elements while obscuring others. Actual flare pistol combat engagements remain difficult to verify. Luftwaffe records mention several instances of pilots reporting illumination devices fired at their aircraft by damaged enemy bombers. Soviet records reference similar events but provide minimal detail. RAF records include scattered references to unconventional weapons employment, but rarely specify outcomes. American records are most detailed, particularly regarding Pacific theater operations where damaged aircraft frequently faced multiple Japanese fighters and conventional options were quickly exhausted. The most thoroughly documented case involves a U.S. Navy TBF Avenger torpedo bomber returning from a strike mission near Truk in February 1944. The aircraft, flown by Ensign George Plant, was attacked by multiple Zero fighters after becoming separated from its formation. Ammunition was exhausted. The rear gunner fired a flare pistol at a Zero approaching from the port quarter. The flare entered the Zero's engine intake and ignited fuel vapor inside the cowling. The Japanese fighter began trailing smoke and broke off the attack. Additional Zeros continued pressing but eventually withdrew. Plant's aircraft reached friendly territory and ditched near a destroyer, which recovered the crew. Debriefing records include the flare pistol incident, noted specifically because the rear gunner requested commendation for innovative weapons employment. No commendation was issued. Doctrine prohibited the use of weapons. Officially, the engagement never occurred as described. Post-war analysis of flare pistol effectiveness was never systematically conducted. The weapons remained classified as emergency signaling devices. Training manuals continued to prohibit their use in combat. Anecdotal accounts persisted among veteran pilots, mentioned in memoirs and interviews, but absent from official histories. The Korean War saw at least one documented instance of a U.S. Air Force pilot firing a flare at a pursuing MiG-15, though the outcome was not recorded. Vietnam War aviators carried flare pistols, but no combat use was documented in accessible records. Modern military aviation has largely eliminated flare pistols, replacing them with electronic locator beacons and integrated survival radios. The weapon that occasionally, marginally, desperately allowed pilots to defend themselves when all proper defenses had failed no longer exists in cockpit emergency equipment inventories. The pilots who used them, who survived against probability by converting signaling devices into improvised weapons at close range in damaged aircraft while under direct attack, are nearly all dead now. Their actions exist primarily in scattered debriefing reports, marginal notes on mission records, and stories told decades after the fact, with details softened by time and trauma. What remains certain is this. In perhaps a dozen documented cases across all theaters of World War II, aircrew fired flare pistols at enemy attacking fighters. Some missed entirely. Some connected but caused no significant damage. At least 3, possibly 5, may have contributed to enemy aircraft being damaged or destroyed. The exact number will never be known. The flare pistol was never designed to save lives through violence. Occasionally, desperately, it did anyway.